Hey everybody, we are getting ready for the next lesson in Tennessee Revealed Geometry, which is lesson 2-3, two-dimensional figures. This is where you're going to learn your area, perimeter, and I got some tricks for you as we go. All right, so let's get into it. So let's see, what page are we on? We're on page, I don't know what page we're on. I tried doing the workbook, and for some reason it wouldn't show the extra stuff that I was doing for you guys to understand, so I'm having to recreate this video. And I've got, as you can see, the background, the GeoGebra open, because I was taking snapshots and doing things for you, and it wasn't working out right. All right, so let's get into this. All right, polygon. It's a closed figure, so the smallest polygon you can have is a triangle because it has to have sides, and they have to be straight sides naturally. Otherwise, they wouldn't be sides. But the smallest one's a triangle. Has three sides. Anything bigger than that. Perimeter is when you're looking at the sum of all the sides. So for the triangle, you would add up all three sides. If it's a pentagon, you add up all five sides. If it's a decagon, you would add all 10 sides. All right. Now, circumference is for circles. Of course, circles don't have sides, so it's a little bit different. We're going to talk about that, but it is still the distance around the circle itself. Area is what's going on inside a figure. Like, for instance, when you're laying tile, you need to know how much tile to have for a specific room or a house or whatever you're doing. Same for carpet. Is how much is being laid down inside of something, as opposed to like the baseboards that you see in a house, or crown molding that's at the top of your at the top on your ceiling. All of that is only going around the perimeter of it. All right, let's see. We've got formulas here. Like I said, adding up our triangle, add all four for a square, add all four for, looks like this is a rectangle, and again, circumference is a little bit different. I like diameter times pi because on the ACT, they like to keep things in terms of pi instead of rounding to get a decimal. So it's a lot easier to say, okay, I have a diameter of 10, so the answer is going to be 10 pi. Or I have a diameter of 2, so the answer is going to be 2 pi. All right. Formula for area is 1/2 base times height for the rectangle, side times side for the square. Some teachers call it length times width. Some teachers call it base and height. Same thing. And for the circle, it's pi r squared. So you take your radius squared, then you stick a pi symbol right behind it if you're talking about standardized tests like the ACT. All right, getting more on down. All right, equilateral, equiangular, and regular. Equilateral, equa means equal, and lateral are your sides. So equilateral means all your sides are the same. Like on a square, all four sides would be the exact same. Equilateral triangle, all three sides would be the exact same. Equiangular, equa meaning equal, and angular is for angles. You would have all four angles are the same. For instance, this rectangle right here, all four angles are 90. So this is equiangular, but not equilateral. This square is both equilateral and equiangular, which means it is what we call a regular polygon, because regular polygons are both equilateral and equiangular, but they also have to be convex. So let's get into what convex and concave are. Convex is when you have no interior points. Concave is when you do have interior points. And if you're a visual person, you can kind of see right here, this is a convex triangle because no point or angle is on the inside of the figure. And this figure, 1, 2, 3, 4, this quad, whatever it may be, is a concave figure because it does have an interior point right there. One of the points is on the inside of the figure. All right, let's see what we're doing down here. Looks to me like we are finding perimeter. Is that what we want to do? Example 1, find perimeter or circumference and area of the figure. Okay. I see they're doing distance. All right, so let me be perfectly clear. I don't like using distance. It is a formula that my students never learn. I am at a school where we teach geometry to sophomores, and we do not offer really the ACT until spring for the juniors. So you're talking about over a year or year that my students are not going to remember this formula for the ACT. So I don't teach it this way. I teach it with Pythagorean theorem. That's why I've got my GeoGebra pulled up, because it's just easier for my students to understand. So I'm going to do a shortcut. And if you're a teacher who prefers distance formula, then that's wonderful. My shortcut is going to give you the same numbers right here anyway. All right, so I've got my GeoGebra pulled up. Even if you're not familiar with GeoGebra, you might want to consider getting familiar with that, because it's really great for my visual students. And you can see you can go in and out. But I want to have it so that I have straight up marks by 1. What I mean is this. I'm moving 1, 2, 3, 4, and out -1, -2, -3, -4. Okay, so the reason why I did this is because I want to draw a right triangle from A and then over to D, because I just prefer to count blocks. Pythagorean theorem will give me the distance from A to D, which nicely is, is the same as the distance from B to C, because we all know that a rectangle has opposite sides congruent. So if you have visual students, this is not a bad thing to do. I'm going to go over here to segment, and I'm going to make AD into a right triangle. So I'm going to come straight down, and it ends up being 1, 2, 3, 4 blocks. And from E, I'm going to come straight over to D, and it ends up coming over 1, 2, 3, 4 blocks. So the Pythagorean theorem is going to be a 4 squared plus 4 squared, and it's going to equal C squared. Like I said before, it's going to come out to be the same thing, because if I have 4 down and then 4 blocks over, you get exactly what happens here. I'm sorry, this is A to D. All right, so let me scroll for A to B. So I get exactly what happens here. 0 minus a -4 is 4 squared, and that's exactly what I got by counting. So I'm going to put in 4 and squared. And -2 minus 2 is a -4. So here I go again. -4 squared. All right. Well, 4 squared plus 4 squared. 4 squared is 16, plus 4 squared is 16. So I'm looking at 32 squared. Of course, then you want to square root that. So I guess it's wanting me to skip a step. So I'm doing 32 squared, or the square root of 32, excuse me, and simplify that. That is going to be on your calculator approximately 5.65. All right, so I'm going to shoot back up to AD, which means I'm counting from A up and then over to D. So for you visual people, I'm going to move this so you guys can see. I'm sorry, A to B. So I'm going to go up and then over. And if you're a visual person like myself, go ahead and click on this segment so you can see what's going on. I've moved up 1, 2, 3, 4, 5. So I'm level with the B. And then I'm going to go over 1, 2, 3, 4, 5. So my Pythagorean theorem is going to be 5 squared plus 5 squared. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So 5 squared plus 5 squared. It's the same thing as what I'm getting right here. 1 minus a negative, same thing as 1 plus 4. And that's going to be 5 squared. Seven minus 2 is 5. So I've got another 5 squared. Just like I said with the Pythagorean theorem. 5 squared plus 5 squared, well, that's 25 plus 25 is the square root of 50. So I'm going to put square root of 50. Now listen, you might be a teacher who is going to teach breaking down radicals. In Tennessee, we do teach breaking down radicals in Algebra 1 and Algebra 2. So my students have seen it before. It doesn't mean they remember it, but they have seen it before. So keep that in mind. And you might be a teacher who's okay with having a decimal. And in that case, the square root of 50 is approximately 7.1 or 7.07, how you want to do that. All right, then you got to add them all together. All right, so let's see. So that's going to be 2 square roots of 50. And if you're breaking that down, that would be 5 square root of 2. And plus 2 square root of 32. And then, of course, I guess they prefer the decimal at the very end. And its perimeter is about 25.5. Okay. All right, here we go for area. Well, I already have my length and my width by doing the Pythagorean theorem or distance formula if you're doing that, and that's fine. So I'm going to do the square root of 50 times the square root of 32. And the reason why is because length times width, or if you prefer base times height, you're just multiplying the two things. So I'm going to do square root of 50 times square root of 32, and you can see it gets a 40, so your area is 40 square units. Okay. Okay, a circle is a little bit different, but I am still going to do the Pythagorean theorem. I see that they do the distance formula, and that is fine. These numbers right here are the exact same ones I'm going to get by doing the Pythagorean theorem. So I'm going to show you on GeoGebra how to do this. So I'm going to get rid of all of this. Okay, you can see where I was testing it out. All right, so let's see. We have a circle with center 4, 8 and a dot on the circle at 6, 3. So I'm going to put 4, 8 to 6, 3 on my GeoGebra. But I'm going to come over here to circle. All right, and they want me to have a circle. Oops, I need to move it out some. Need to do 4, 8. So circle it 4, 8. And then 6, 3 is where I want my dot. So I'm going to come over to 6, 3. Okay, so now I have recreated what they have. There's my circle. So the first thing I'm going to do is I'm going to draw a segment to show what my radius looks like, which will happen to be the hypotenuse of my right triangle. So here's my radius. I'm going to draw a segment from 4, 8 to 6, 3 from C to D. Feel free to pause this video if I'm going too fast. But as you can see on GeoGebra, what I really like is it goes ahead and gives me the distance here. So I already have my answer for the radius anyway. But listen, I'm showing you guys a little trick. So I'm going to turn this to a right triangle by starting at C, coming straight down and counting blocks. And then since I'm level with D, over to D. Don't go all the way to the circle because, again, that's a radius. I want to make this to a right triangle. So I'm going to come down till I'm level with D and then over 2 blocks. And you'll notice that I went down 5 and over 2. But if you're a visual person, you might be sitting there going, what's she saying? I don't get it. So start at the center. I'm going to come straight down till I'm level with B, not all the way to the edge of the circle. And I'm going to come over till I hit B, and there's my right triangle. I'm going to count blocks. 1, 2, 3, 4, 5. So I've got 5 squared plus 2 going over, 2 squared. So my Pythagorean theorem is 5 squared plus 2 squared. And like I said, that's the exact same numbers you're going to have underneath this square root right here. So 5 squared plus 2 squared, that's going to be 4 plus 25 is 29. So my radius is the square root of 29. That's approximately 5.4-ish, 5.4-ish. All right, so circumference. I see they're using 2 pi r here. I prefer diameter times pi. So I'm basically going to multiply this radius times 2 to find my diameter. And I end up with about, 10.7 or so. 10.8 if you're rounding to the 10th place. But, okay, so they're multiplying by 3.14 as well, it looks like. So I'm going to multiply that by pi in my calculator. That's where they get the 33.8. I like that they're not rounding in the middle of the problem. It looks like they are rounding at the very end. All right, area is pi r squared. So we're going to go back to the square root of 29, square that number, which really ends up just getting rid of the radical. because a radical and a square are opposites. They cancel each other out. So we have 29 pi left. And if you don't believe me, try it out. Grab you a calculator to the square root of 29. Do not round. Square the number that's on your calculator, and you're going to end up with a 29, because a radical, square root, and a power of 2, they cancel each other out. If it's a cube root and you cube it, they cancel each other out. If it's a fourth root and you put it to a power of 4, they cancel each other out. So a nice little shortcut. So 29 pi, I like that because that's how the ACT is going to have it. They don't like decimals. But 29 times the pi button on your calculator, not 3.14. Please get out of that nasty habit. 29 times pi is about 91.1. All right, so we got a question coming up, a check. All right, so try it out yourselves, everybody. Take this circle on your notebook, draw yourself a segment from D, the center, to C, which is a point on the circle. This is going to be your hypotenuse of your right triangle. From C, you're going to come straight down till you'll level with D, count your blocks, come over to D, count your blocks, and that's the two numbers you're going to use for your Pythagorean theorem. So 1, 2, 3, 4, 5, 6, 7 down. 1, 2, 3 over. So we got 7 squared plus 3 squared. 7 squared plus 3 squared. That's going to be your Pythagorean theorem you're going to use. Get your radius. All right. Circumference is diameter times pi. So once you get your radius, multiply times 2, and then times your pi button on your calculator, you get your circumference. Area. Once you have your radius, square that number. Remember, a square root and a square cancel each other out. Stick a pi symbol right behind it, or since you have your approximation, multiply by pi and calculate around to the 10th like they ask for. All right. Moving on. All right, so a geometric model is basically a real-world example of a problem that we are doing. And I see they have a real-world example. Looks like use appropriate two-dimensional model and the dimensions provided in the image to calculate the perimeter and area of the plate. Okay, so we have a square plate. I know that because my sides are equal. 12.5 for my base, 12.5 for my height or length and width, if you want to call it that. Doesn't matter to me. All right, so we calculate the perimeter, which means we're going to add up all 4 sides. So 12.5 plus 12.5 plus 12.5 plus 12.5, or if you're looking for a shortcut, 12.5 times 4, because they are all the same. You're going to get a 50 for perimeter. So this is okay, I just want to put a square. All right, so 12.5, like I said, times 4, and that's going to give you 50. So perimeter is 50. All right, for area, you're going to multiply 12.5 times 12.5 because your base and height are the exact same. And okay, so it looks like they want 12.5 squared here. It's the same thing. It looks like you're going to end up with 156.3. All right, so what's going on here, you guys? We got to find, okay, so I see that this is a rectangle. Got your base, you've got your height. So this is a rectangle. And perimeter, you're going to add up all 4 sides. We're going to add 61 with the 61 and the 40.6 with your other 40.6. 61 plus 61 plus 40.6 plus 40.6. Looks like we got 201.2. And area, base times height, so 61 times 40.6. All right, woo, big number, big number. All right, so you should have 2,476.6, and that's squared centimeters. Remember, area is just length times width or base times height, however you want to look at it. All right, example number 3. They really kind of did it for us, it looks like. So 15 times 15, or 15 squares, 225 square feet. All right. Circumference, no, C. What's going on here? Okay, just the counter is labeled C. So 3 times 11 is 33. And all right, looks like we get a triangle for the drink station. And the formula for a triangle is 1/2 base times height. And if you get stuck, you can just count it over how many blocks and up how many blocks. So it looks like it's 6 over and 5 blocks up. So that's where we get your 1/2, 5 times 6. Well, 5 times 6 is 30, and half of that's 15. All right. Let's see what we're doing here. Areas for the tables. Okay. Oh, okay. Here we go again. Just counting. We can count blocks and count blocks up and over. And it looks like they did it kind of really for us. Square root of 20 times the square root of 5. Well, a square root times a square root gives you a squared. So if you don't believe me, take the square root of 20 times the square root of 5 on your calculator. You're going to end up with a 10, because a square root and a square, remember, they cancel each other out. So really, it's just 20 times 5. Then you're multiply times a half, or take half of that. All right, so that's going to be a 10. All right. Square root. I think I said that. I think I did say that wrong. My apologies. Square root of 100 to 10. All right, so let's see what's going on here. Area, the cafe. All right, so 225 minus 33 minus 15 minus 2 times 5 is, 2 times 10 is 20. And it looks like we're going to get 157. All right. I think I'm going to leave the rest of this for you guys to do, because I'm getting short on time. And, sometimes you got to go through and figure some things out yourself. All right. Let me know if you have any questions. Ask your teacher. That is what we make the big bucks about. Not really, but yeah, there you go.